finally we're going to get some rules for finding antiderivatives. So far, you have been kind of left to grope in the dark for those. But today we'll cover the basic rules. And then later in this unit, we'll start getting to, well, what if the basic rules don't work? Then what? So first of all, the general antiderivative, which says if capital F of x is an antiderivative of f of x on an open interval from a to b, doesn't matter about the endpoints, then every other antiderivative on that open interval from a to b is of the form capital F of x plus c for some constant c. Because if you add on a constant to capital F of x and then take its derivative, what happens to the plus c?
Non-zero.
It's zero. So that's why that's true. So we always say an antiderivative instead of the antiderivative because there are an infinite number of antiderivatives for any given function. Now, what we're going to be doing starting today is something called indefinite integration. What we've been doing so far is evaluating definite integrals, where you're finding a numeric value. Here, we're finding what is an antiderivative of the original. So if you've got the integral of f of x dx is equal to capital f of x plus c, means that capital F of x prime is equal to f of x. And we call capital F of x plus c the general antiderivative or the indefinite integral of f of x. All right, so let's start with the power rule. You have kind of figured this out already. The integral of x to the nth dx is equal to x to the n plus 1 over n plus 1 plus c. Just real quickly, I'll add that I usually think of it more like this, as 1 over n plus 1, and I know it's not that different, times x to the n plus 1 plus c. You multiply by the reciprocal of the new power. It's not always underneath the x. In fact, unless n is a whole number, I almost always write it out in front. Another antiderivative that you need to know is if y is equal to x to the negative 1 or 1 over x. Remember, those two are the same thing. So the antiderivative of either of those is the natural log of, notice, we slap on some absolute values here. Why? Well, because natural log is not defined for anything that's negative. It's only defined for positive numbers. So let's use those ideas to find antiderivatives. So evaluate this integral. So I always start with, when it's a polynomial, with the power rule part. So that's going to be x to the fifth. And the 3 will be multiplied by 1/5. So that's 3/5 x to the fifth. We add 1 to the power and multiply the coefficient by the reciprocal of that new power. Then minus, this is going to be x to the 5/3. And we're going to multiply my 5 by the reciprocal of 5/3, which is 3/5. 5 times 3/5 is 3. Plus, negative powers, I don't know why. When you're doing derivatives, people don't have as much trouble with it, but sometimes people have trouble with it. It's too strong, but will make mistakes where you're supposed to be adding 1 to the power and you accidentally subtract 1. So just be careful of that. So we're adding 1 to the power, so that'll be to the negative 2. So this will be negative 1/2 x to the negative 2, all plus c. Do not forget the plus c on an indefinite integral. That's the kind of thing where if you're doing that on a quiz and there's 10 of them, well, it's a point off every time. Hello, one grade lower than you should get, right? So something to be careful about. All right, let's take a look at this next one. The 5 over x, that's 5 times 1 over x. And the antiderivative of 1 over x is? Of what? Close, but no banana.
Absolute.
There we go, absolute value of x. And then I'm going to have x to the negative 9th power. So I'm going to multiply the reciprocal of negative 9, which is negative 1/9, times negative 3, and I get positive 1/3, all plus c. So that covers any power. And then we can undo derivatives of trig functions. So the antiderivative of sine is negative cosine. The antiderivative of cosine is sine because the derivative of sine is cosine, right? You just have to think in reverse. And then, the rest. These are all, you're very familiar with the derivatives of all of these. We also have integrals involving e to the x, and it's really nice. Remember, the e to the x is its own derivative, so it's also its own antiderivative. So an antiderivative of e to the x dx will be e to the x, and then plus some constant. Now, one thing that comes up, and we'll get to how to do this if it's more complicated, is this idea of a linear argument. So what we're saying here is that if you have the integral of some function, doesn't matter what this function is, but it's not just f of x, it's f of k times x plus b. I don't know why we used k, we could have used m, right? It's a line. When you take the antiderivative of that, you do the antiderivative as normal, but you multiply by 1 over k. Now, why do we do that? Why do we multiply this by 1 over k? Any thoughts?
Because when you take the derivative, it's not going to be the same.
Yeah, because of...
That one question I asked you about.
Okay, so when you take the derivative of this, you're going to keep the 1 over k. How does that 1 over k get gotten rid of when you take the derivative? Okay, you're on the right track. So the derivative with respect to x of 1 over k times capital F of kx plus b plus c is equal to 1 over k times f prime of kx plus b, and then what do I have to do to take the derivative of this? Pardon? Yes, there we go. Chain rule times k, and that cancels this. Okay, so that's where that 1 over k comes from. Is it balances out that constant that you would generate when you take the derivative of your antiderivative. Okay, it balances out the chain rule part. Okay, so let's do a few more examples. Here we want to evaluate the integral of 3 e to the x minus 4. What's an antiderivative of 3e to the x? It's not a trick question. You guys are very timid this morning. Thank you. 3e to the x. Yeah, that's exactly right. And what's an antiderivative of negative 4? Yeah, negative 4x, exactly right. We haven't talked about that specifically, but you can think of negative 4, you don't need to write this, but negative 4 is negative 4x to the 0 power, right? If you take the antiderivative, you would add 1 to the power and multiply by the reciprocal. Well, that's negative 4x to the first. So it is an application of the power rule. It's just that we don't normally think of it that way. I think of it as, all right, well, the only way I can get a constant is if this was a linear term, right, when I take the derivative. All right, let's look at this next one. Somewhat similar to the first part of the last one, but notice we have this function within a function, a composite function, and the inner part is linear, right? It's negative 3x plus 7 if you want to put it in sort of more the standard order. So this is going to be 12 over negative 3 e to the 7 minus 3x plus c. So we're multiplying by the reciprocal of the derivative of this linear term. So that's just going to be negative 4e to the 7 minus 3x all plus c. So using that same idea, what am I going to have to multiply by when I have sine of 8t minus 3 and I want the antiderivative? 1/8. And the antiderivative of sine is negative cosine. So that's negative 1/8 cosine of 8t minus 3. Then what are we going to have to multiply this 20 by? 1/9. So that's going to be, no, not 29, 20 over 9. And what's the antiderivative of cosine? Sine. So it'll be plus 20 over 9 sine of 9t plus c. We're finding the general antiderivative, so they should all have plus c's on them. Any questions? Okay.